Okay, example 3. Again, solve the system of linear equations by graphing. So what is our system? Our system is y equals 3x minus 2 and 15x minus 5y equals 10. So again, the first one's going to be my line 1, and the second one is going to be my line 2. So let's graph line 1, and notice line 1 is already in slope-intercept form. So let me put white. So y equals 3x minus 2. This is ready to go. Again, you can use the intercept method, but it's ready to go, right? There's your slope, y equals mx, and there's your plus b. So we know our slope is 3, or 3 over 1, right? That's my rise over run, which is going to be going up 3 to the right 1. And what's my y-intercept? What's the point on the y-axis? That is always 0, comma, and then our b is negative 2. So we're done with this one. It's done. So let's quickly plot those points. And let's see. So we have let's see, my x-axis and y-axis. So 0, negative 2, well, it's definitely down here. And from here, remember your slope, let's use yellow, right? The rise over run, this guy, right? This is your navigator, right? This is your guide. It's telling you where to go from that point. So I'm going to go up 3. So 1, it's 1, 2, and then 3 is at 1. Right? So there's my up 3. And then I'm going to go to the right 1. Right? There's my, well, to the right 1 or plus 1. And then there is my new point, right? A point is 1, comma 1 if I graph it. So let's see. Let me get pink. And there is my line, my L1, right? And notice my slope, right? Which, I mean, this guy is sometimes called M1 because it's the first slope of the first line. And notice M1 is positive, right? That means it's positive, right? Because it's greater than 0. Because if you're walking up the line, well, if you're walking on the line, you're going up. Okay, so let's do this for the blue, right? The blue, the second line. And this guy is not in slope-intercept form. I'm going to go ahead and put it in slope-intercept form again, just to practice both. Again, if you want to use intercepts, that's completely fine. Minus 5y equals 10. Okay, so we get, if I wanted to put it in slope-intercept form, I'm going to subtract 15x, right, from both sides. Why? Because I want to isolate y, right, and now I'm closer to isolating y with moving that 15x over. I'm going to write my x first, and then my constant, and I want y equals mx plus b, not negative 5y. So I'm going to divide both sides by the coefficient, which is negative 5, right, to each term. Negative negative is positive. This is a big 1, right? 5 again. This is just a big 1. And so I get 1y, or y. Positive positive, this is 3x minus 2. And again, here's the slope. Here's the y-intercept. And what do you notice? What's the relationship? What was our slope for the other line? Well, it was exactly, it's exactly the same, right? There's y equals 3x minus 2. And then I also get y equals, y equals 3x minus 2. I mean, so technically you really have y equals 3x minus 2 and y equals 3x minus 2, right? This is line 1 and this is line 2. But, I mean, these are really equal. So here, when we graph the blue line, right, it's just really on top of that red line. And so where do they intersect? Well, they intersect here, 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 here. I mean, they intersect everywhere to infinity and beyond, like Toy Story. So, I mean, because the line keeps going on forever. So here, how many solutions are there? There's infinitely many solutions, right? It doesn't just intersect at one point. It intersects at infinitely many points. And our system, right, is consistent. Because again, they intersect at every single point. So again, we've done 3 cases, right? Example 1 is where they have specifically one solution. Example 2, they have no solutions because they're parallel lines. And example 3 is they're the same line. So again, make sure you have a straight edge on Friday.